So have you ever like walked right up to a door, grabbed this massive obvious metal handle and just pulled with all your might?
Oh, and it's a push door.
Exactly, it's a push door. And usually someone is watching you do it.
Naturally. It always happens when there's an audience.
Right. And your immediate reaction, I mean, you probably mutter an apology, right? You blame yourself.
Yeah, you think, oh, I'm just clumsy.
Exactly. You think it's a flaw in your own intelligence. But back in 1943, there was this aviation psychologist who realized something that kind of fundamentally changed the modern world.
And that realization was that it is almost never your fault.
Yes. The flaw isn't you. The flaw is the design. And that is exactly what we are getting into today. Welcome to this deep dive.
Yeah, we are tracking a century-long evolution here.
We really are. We're looking at how the tech industry actually figures out what you and I want. I mean, going from researchers literally using stopwatches to, optimize bricklayers.
All the way up to 2026.
Right, where we're using like AI-powered synthetic users in the cloud. It's wild.
It's a massive shift. I mean, from a user research perspective, moving from blaming the human to actually studying the human is, well, it's the biggest intellectual pivot in industrial design history.
For sure. And to guide us, we've got a really fascinating stack of sources today.
We do. We're looking at these 100-year historical reviews of human-computer interaction, or HCI.
Plus some incredibly deep academic papers on ethnographic methodologies.
And, of course, the bleeding-edge stuff, the 2025 and 2026 industry reports from Maze and UX Tigers.
Those reports are incredible. They map out exactly how generative AI has just completely rewired the user research tech stack.
Yeah, the mission today is really to deconstruct how researchers capture the mechanics of human behavior, right?
Yeah.
And how massive shocks like COVID and the AI boom just reshaped everything.
Exactly. And, provide you with some practical cutting-edge strategies for doing user testing right today. So, okay, let's unpack this.
Let's do it. And I think, from my perspective as someone who has led research teams for a long time, it's important to remember that while the tools have changed wildly, the core goal understanding human behavior, that hasn't changed at all.
Right. It's still about the human. So
Yeah.
let's start with that 1943 aviation psychologist, because that's where this whole blame the user mentality finally broke.
Yeah. Yes. Alphonse Trapanis.
Japanese. So during World War II, the military was dealing with this massive, horrific problem, a huge number of crashes in their B-17 bombers.
Yeah, the pilots were retracting the landing gear while the planes were literally still on the runway.
Which is catastrophic. And the military command, they just kept writing it off as pilot error. They figured, these guys are stressed, they're exhausted from combat, they're just making stupid mistakes.
Right, but Trapanis completely rejected that premise. He actually went into the cockpit and looked at the physical layout of the controls.
And what he found is it's so incredibly obvious in hindsight.
It really is. He saw that the toggle switch for the landing gear and the toggle switch for the wing flaps, they were identical.
Identical in shape, right? And positioned right next to each other.
Exactly, side by side. So you had these pilots operating under immense cognitive load, usually looking out the windshield instead of at the dashboard.
And they're just reaching down and grabbing the wrong identical switch.
Exactly. So Chapanese comes up with a brilliant mechanical solution. He attaches a small rubber wheel to the landing gear switch.
Because landing gear has wheels.
Right. And then he attaches a small wedge shape to the flap switch.
Wow.
Just by altering that tactile feedback, the error rate dropped to 0, almost overnight. He proved that what the military universally considered pilot error was fundamentally designer error.
It's like the difference between forcing someone to wear a shoe that's 2 sizes too small and blaming their foot for hurting.
Versus finally deciding to just measure the foot to build a better shoe.
Exactly. But it took so long to get there. To understand why the default stance was to blame the human, we kind of have to rewind another 30 years, right?
Yeah, back to the 1910s, the industrial efficiency movement.
Right. Frederick Taylor and the Gilbreths, they weren't looking at users as like complex psychological beings.
Not at all. They viewed the human body as an inefficient motor that simply needed optimization.
It's so dystopian. Frank and Lillian Gilbreth, they pioneered this thing called motion deconstruction.
Yeah, they wanted to eliminate wasted physical effort on assembly lines. They invented these things called cycle graphs.
Which were basically tiny light bulbs attached to a worker's fingers, right?
Yes. They'd use long exposure photography to trace the exact physical path of a movement.
So if a bricklayer had to bend over too far, the photo would show this chaotic, tangled web of light trails.
And then the Gilbreths would redesign the physical workstation, like raising the bricks up to waist level, until that light trail became a smooth, singular arc.
They even applied this to the military in World War I, training soldiers to assemble weapons in total darkness.
Right, because they realized that visual reliance actually slowed down the physical mechanics.
They turned the human into a faster machine. But the limitation is so obvious now, you're only measuring the output of the hands.
Exactly. You're completely ignoring the processing power of the brain.
Which works fine if you're just moving bricks. But once machinery evolved into early computing and communication networks, the cognitive load totally eclipsed the physical load.
You can't use a stopwatch to measure how long it takes someone to understand a confusing instruction.
Right. You need a new discipline entirely. And that brings us to 1945, Bell Labs.
A huge milestone.
Massive. Bell Labs was arguably the most advanced engineering organization on the planet. And they do something that must have seemed insane to their electrical engineers.
They hired a psychologist, John E. Carlin.
Bringing a psychologist into an electrical engineering department?
It was a formal acknowledgement that the circuitry of the human mind was just as critical as the circuitry of the telephone network itself.
And Carlin really established user preference testing. His biggest legacy, the one we still use every day, is the touch-tone telephone keypad from the 1950s.
Yeah, the engineers had the tone technology ready, but they didn't know how to arrange the 10 digits on the pad.
And I always found this fascinating because the calculator layout already existed, right?
Yeah.
The 7, 8, and 9 were across the top row.
Right, but Carlin didn't just lazily default to the existing standard. He ran rigorous cognitive tests.
Testing all sorts of weird stuff.
Oh yeah, circular layouts, 2 vertical columns, cross shapes, everything.
And what did they find?
They discovered that people read and processed information top to bottom, left to right. Putting 1, 2, and 3 on the top row aligned seamlessly with alphabetic reading progression.
Makes total sense.
The calculator layout felt cognitively backwards for a communication device where you're dialing a sequence, not doing math.
And getting that UX right in the foundation shapes human behavior for a century. The layout Carlin finalized is the exact same one on the smartphone screen in your pocket today.
It creates a frictionless interaction.
Based on the retrospective data in our sources, that specific design has been used to place an estimated 40 trillion calls.
It's staggering. But, designing a keypad is relatively straightforward compared to what came next.
Right, the transition to software.
Exactly. Moving into the graphical user interface era, the Xerox Alto, the Apple Lisa, in the early 1980s, the research methods had to get significantly more sophisticated.
And this ushers in what the sources call the classical lab era of HCI. Software isn't just buttons, it's layers of navigation, hidden menus, desktop metaphors.
You couldn't just observe someone's fingers anymore. You had to capture their confusion in real time.
And setting up a usability lab back then sounds like an absolute nightmare, like building a TV broadcast studio.
It really was. Researchers needed highly controlled environments. They used bulky analog tapes and later early digital formats like Sony's -H or DE.
And the synchronization was the hardest part, right?
What's fascinating here is the technical friction. A researcher needed to see the precise moment a user frowned and correlate that microexpression with the exact pixel the mouse cursor was hovering over on the screen.
So they had to lay down SMPTE time codes on the video feeds.
Physically locking the video of the user's face to the video output of the monitor. It was a massive logistical undertaking just to analyze a single 1-hour session.
It's crazy. But despite that friction, this sterile environment birthed the methods we still use, like the Think Aloud protocol.
Formalized around 1980 by Anders Ericsson and Herbert Simon.
Yeah. And it sounds so simple, just ask the person to narrate their internal monologue. I'm looking for the save icon.
But the mechanism behind it is rooted in deep cognitive psychology. It forces the user's working memory out into the open.
Because designers suffer from the curse of knowledge, right?
Exactly. We know how the system works, so our brains automatically fill in the gaps. When a novice user verbalizes their thoughts, they expose the exact moment their mental model diverges from the system's conceptual model.
You literally hear the friction before the error happens on screen. But our sources point out a massive structural flaw with this, especially globally.
Right, the assumption that verbalizing thoughts is culturally neutral.
Which it definitely isn't. The academic papers show a huge behavioral divergence between Western users and East Asian users here.
It maps directly to low context versus high context communication styles. In Western low context cultures, explicit verbalization is totally natural.
But in many East Asian high-context cultures, meaning is derived from context, silence, nonverbal cues.
So forcing a user from a high-context culture to narrate every micro-decision can induce severe cognitive overload.
It actually alters their performance. They take longer, they make weird errors just because the testing method itself is distracting them.
It's a textbook observer effect. The way you measure the phenomenon alters the phenomenon.
Wow. And then there's the Wizard of Oz method, testing things that don't even exist yet.
Coined by Jeff Kelly, a masterclass in risk mitigation. Because writing code is expensive.
So instead of building a complex algorithm, you just put a user in a room with the terminal and a human researcher, the wizard, in another room.
The user types a query, thinking they're talking to a machine, and the human quickly types back the response.
You test the psychological acceptance before spending a single dollar on engineering. Brilliant. But let's look at the math, because these physical labs were incredibly costly.
Very expensive.
How many people did you actually need to test to know if an interface was broken?
This is a huge milestone. In 1992, Robert Verzi and later Jacob Nielsen established the usability scaling law.
The magic number 5.
Yes, they proved statistically that you don't need to test 50 or 100 people. Testing just 5 users will uncover about 85% of the core usability problems.
The underlying math is a Poisson distribution model, right? The formula models a curve of diminishing returns.
Exactly. The first user you test is going to stumble into a massive pile of obvious errors. They'll uncover maybe 30% of everything wrong.
And the second user finds a few new edge cases, but mostly trips over the exact same glaring errors.
By the time you watch the 6th or 7th user, you aren't discovering new insights. You're just watching people suffer through the same friction you already documented.
It validated the whole field of qualitative research. You didn't need massive sample sizes to make things better.
But by the late 90s, the software industry realized they had a different problem. Software was moving from standalone lab tools into chaotic corporate offices.
And human behavior is situated, which triggered what the industry called the turn to the wild.
Hugh Beyer and Karen Holtzblatt pioneered this with contextual inquiry. They basically argued the usability lab was a sterile zoo enclosure.
Right. In a lab, they only focus on your software, but in the real world, they have a Post-it note with task words. They're holding a phone. There's a ledger on their desk.
If you don't understand that chaotic ecosystem, your software will fail miserably in the actual office.
So it's literally like studying an animal in a sterile zoo versus observing them out in the jungle. But wasn't going into the jungle incredibly slow and expensive?
It was. Traditional ethnography takes months. Software teams release updates every 2 weeks.
So how did they reconcile that?
They engineered rapid ethnography. Instead of passively observing for months, they used multidisciplinary teams and a technique called motivated looking.
Motivated looking, meaning you're purposely ignoring a vast amount of data.
Yes, you go in with a highly specific hypothesis. You aren't there to just watch them work. You're there to observe the exact sequence of actions when a customer requests a refund.
You extract the patterns in 3 days instead of 3 months.
But even rapid ethnography required physical presence. And as we move into the 2000s and 2010s, software is deployed to millions of smartphones globally.
You can't fly a team to Tokyo, Berlin, and Sao Paulo every week. The physical tether had to be severed.
Initially, early software like Moray helped digitize the lab, recording the screen and webcam natively. But the real shift was behavioral analytics.
Tools like Google Analytics, Full Story, Hotjar. We went from qualitative observation to massive quantitative tracking.
We instrument the software itself to report back on 5 million people simultaneously. By monitoring the document object model, capturing every mouse movement and click.
Generating heat maps, and they develop these heuristics to flag behavioral anomalies like rage clicks.
Yeah, if a user rapidly clicks a static image 6 times in 2 seconds, the system flags it. It means they expect that image to be a functional link.
Or the U-turn. A user clicks a link, lands on a page, and within a second hits the back button.
It mathematically identifies a failure in your navigational labeling.
Behavioral analytics gave us the ultimate what at a global scale. But here's where it gets really interesting. The final push that completely virtualized user research wasn't software. It was March 2020.
The pandemic. The physical lab became legally impossible overnight.
88% of organizations transitioned to remote work instantly.
And this fundamentally broke the geographic bias that plagued user research. Historically, labs tested weird populations.
Western, educated, industrialized, rich, and democratic.
If your lab is in Silicon Valley, you're mostly testing affluent tech workers in Silicon Valley.
Huge blind spot. But with remote asynchronous testing platforms like Maze or user testing, you send a link, and the user records their session on their own time.
A researcher in London can test farmers in Kenya and accountants in Tokyo on the exact same afternoon. It democratized the sample size.
But the remote communication infrastructure had to be flawless for that to work. And the sources point to the UX case study of Zoom here.
Video conferencing was notoriously high friction before 2020. Accounts, heavy downloads, weird audio routing.
People actively avoided it, but Zoom's teams hyper-optimized the onboarding, the WebRTC standard, the one-click join.
Stripping away account requirements for participants, the UI was engineered to be entirely transparent.
And because of that lowered cognitive load, Zoom scaled from 10 million daily participants in December 2019 to 300 million by April 2020.
It became the fundamental infrastructure that allowed qualitative research to survive.
So we solved the scale problem. We have behavioral analytics. We have Zoom interviews. But that creates a new bottleneck. Data without synthesis is just noise.
Exactly.
If you have 10,000 survey responses, no human can read and cross-reference all of them efficiently.
The human researcher's cognitive capacity became the limiting factor. And this brings us right to the bleeding edge. The 2025 and 2026 reports.
Maze and UX tigers.
They map out how generative AI and large language models completely rewired the synthesis phase. 69% of product teams have integrated AI into their workflows.
Historically, there was a strict trade-off. You wanted quantitative statistical significance. You ran a massive multiple-choice survey. You wanted qualitative depth. You did 5 one-hour interviews.
That boundary has entirely collapsed. We are in the era of qual-quant.
Because LLMs process language using vector embeddings, right?
Yes, mapping words into high-dimensional mathematical spaces. The AI understands semantic proximity. It knows that the app feels sluggish and it takes too long to load, or the exact same conceptual frustration.
It's like a massive water treatment plant. You feed it a fire hose of fuzzy, unstructured human language from support tickets and transcripts.
And the AI acts as the filtration system, instantly clustering semantic similarities and outputting pure, statistically significant trends.
It gives you the deep why at the massive scale of the what. But the AI integration goes way beyond just analyzing data. What about synthetic users?
Ah, yes. The most controversial development in the 2026 reports.
It challenges the very definition of research, pointing an LLM at your prototype and asking the algorithm to test the interface.
You don't use a generic LLM, though. You fine-tune the model on your company's proprietary historical session recordings, demographic data, past analytics.
So you construct a highly constrained AI persona that mimics the known behavioral patterns of your actual users.
Exactly. You aren't looking for nuanced emotional friction here. You're using the AI to execute that usability scaling law, the magic number 5 at hyperspeed.
Deploying an army of synthetic users to find the broken navigation loops, accessibility, contrast issues, dead links.
It's an efficiency mechanism. Harvest the low-hanging fruit with algorithms. Then, when you bring a real human into a moderated session, you use their valuable time for complex emotional validation that AI can't simulate.
But wait, if an AI is doing the initial testing and filtering our data, are we starting to design products for algorithms instead of humans?
That is the existential question right now. Is the human researcher being automated out?
Are they?
If we connect this to the bigger picture,
Yeah.
the data from the 2026 Maze report says no. 82% of researchers state explicitly that interpreting human emotion, cultural context, and ethical judgment cannot be replicated by AI.
So the value of the human isn't gathering data anymore. The machine does that better. It's what the UX Tigers report calls the messy middle,
Right, the translation layer.
where sterile data hits corporate reality.
Exactly. And AI can mathematically prove that 40% of users are failing checkout due to a dark pattern. But the AI cannot walk into a boardroom, navigate the competing incentives of marketing and engineering, and successfully advocate to rewrite the code.
The AI lacks strategic agency.
The researcher's role is evolving into a strategic organizational advisor.
So what does this all mean for teams operating today? Because research isn't just academics in a basement anymore, it's a team sport.
Highly distributed. 70% of designers, 42% of PMs, and nearly 20% of marketers are conducting their own user research now.
But democratization without governance is chaos. The data shows 61% of orgs hand out access to these tools, but fewer than half provide structured training.
You end up with marketing managers running biased surveys and making product decisions on statistical noise. It's a massive risk.
So how do listeners actually apply this? The sources give us 3 practical tips. First, make research methodologies legible.
The UX Tigers report executed this brilliantly. Nobody reads 50-page methodological manuals. So they translated their 12-step usability protocol into a visual comic strip.
Bypassing the academic intimidation factor. A PM looks at a comic panel and instantly understands how to structure a neutral question or avoid leading the witness.
It establishes a baseline of quality. Tip 2 revolves around AI guardrails. You cannot treat the AI as an infallible oracle.
Treat it as an incredibly fast, highly capable, but fundamentally naive assistant.
Right. The AI does the heavy lifting transcription, initial semantic clustering. But the human researcher must maintain absolute oversight over the final ethical interpretation.
Verifying the source data so the AI didn't hallucinate a trend or strip away marginalized context just to find an average.
Exactly. And tip 3, build systems of learning, atomic research models.
Instead of a static PDF report dying on someone's hard drive, break insights into searchable, tagged nuggets in a centralized repository.
Research stops being an event and becomes a compounding asset. Context dictates the method. Minor tweak, remote unmoderated AI test, medical hardware, physical lab observation. The scientific method is the constant.
We've gone from stopwatches to synthetic users, but the final provocation from the UX Tigers report is wild. The future might dissolve the interface entirely.
Generative UI. For 40 years, interfaces have been static. Designers build a screen, you learn to navigate it. Generative UI upends that.
The interface is generated dynamically on the fly by AI based on your immediate intent.
Instead of clicking 5 menus, you state your goal, and the AI physically generates a bespoke dashboard just for that interaction, and then it dissolves.
Ultimate friction reduction. But it radically alters the researcher's job. You can't test a screen that doesn't exist yet.
You'll have to pivot to studying user intent and user-generated innovation, understanding what users are prompting the system to build.
And building the ethical guardrails that shape those generated interfaces. We're moving from measuring the foot to build the perfect shoe.
To designing an adaptive material that automatically wraps around whatever foot steps onto it.
It's incredible. The tools change, but the core objective remains understanding human intent. Thank you for joining us on this deep dive into human-computer interaction.
It's been a great journey.
Whether you lead a product team or just navigate complex software daily, look closer at the interfaces you use. The friction you feel is data. Keep analyzing, keep questioning the design, and we will catch you on the next deep dive.